Hello and welcome to After School. The subject is physics and the topic is graphs, velocity time graphs, acceleration time graphs, distance time graphs, and all of that. Before I start, it is important to let you know that physics is a branch of science which studies matter in relation to energy. Physics can also be said to be a branch of science which deals with measurements. All of this put together, it is important to note that physics has two major branches: mechanics and fields. That is just an introduction. Back to graphs. The question here says, explain the graph below and calculate 1. Acceleration, 2. Retardation, 3. Distance covered after 5 seconds, and 4. Total distance covered. It is important to note that in physics, we try to represent motion in a field, and when we do this, we end up forming a plane figure. It could be a triangle, it could be a rectangle, it could be a trapezium, and so on and so forth. So as a student of physics, on paper you can represent motion as a shape and then calculate distance and all other things we have mentioned here. This is the graph in question. When you look at this, it is important to note that this graph did not start from the origin. In a graph, you have the vertical axis, which is the y-axis, and you have the horizontal axis, which is the x-axis. Looking at the y-axis, it is not starting from 0, which is origin, meaning it starts from 5. To explain this graph, what it means is that the body took off, not from rest. It didn't start from 0, meaning it did not start from rest, in which case initial velocity u will not be 0. So our initial velocity will be 5. It started from 5, accelerated positively to 15, final velocity, and now had a uniform motion, constant motion, which lasted for 5 seconds. The positive acceleration also lasted for 5 seconds. So the uniform acceleration uniform velocity lasted for another 5 seconds, which is what we have under here, and then began to decelerate. The deceleration is what is represented under the part called c. So there was a positive acceleration, constant or uniform acceleration, and retardation. I take that again. The velocity was positive, in which acceleration would be positive, constant here or uniform, and then negative, what we call retardation or deceleration, that is negative acceleration. Positive acceleration, uniform, and negative. Coming to the questions expected of us to solve, the first one is acceleration. We will use the formula, one of the equations of motion, which is v is equal to u plus at. And going by that, like I had explained, you will understand that the acceleration in question has to do with the first part, which has been labeled A here. The first part of the shape, labeled A. So applying this formula, equation, we have 15, which is the final velocity reached, is equal to 5 initial velocity plus A, which we are looking for acceleration, times the time, 5 seconds. It took 5 seconds for the positive velocity, positive acceleration. So going by that, when we calculate this, we can just make A the subject of the formula and have V minus U all over T, which is 15 minus 5 over 5. 15 minus 5 is 10 all over 5. So the acceleration in this motion is 2 meters per second squared. 2. Retardation. I have told you, or I have told you, that retardation is is negative acceleration. So the retardation in this case will be 0 minus 15. Retardation is negative, so it will be 0 minus 15, and that's what we have here, because it is a twist. When you're looking at positive acceleration and negative acceleration, it's like a reverse of the other one. So instead of 15 being our final, we are going to, being our initial, we are going to take it as, sorry, being our final, we are going to take it as initial. So in which case we'll have 0 minus 15 and have minus 15 all over 5, which will give us minus 3. That is negative acceleration. Note, there is a twist. It is a reverse of positive acceleration. So if in positive acceleration we had 15 as final velocity, in this case we are going to have it as initial velocity. That is why there is this reverse. So the retardation is minus 3 meters per second squared. Question 3 says, calculate the distance covered after 5 seconds. Like I told you, the shape that has been formed is what we use. We calculate the area, and when we calculate the area of the shape formed, it gives us the distance covered. So for this case, distance covered after 5 seconds, we can forgo. If you use the calculation here, you'll be able to find it. But what I am saying is that you apply another equation of motion. There are 2 you can use in this case. We have v squared minus u squared plus 2as, and then s is equal to ut plus half at squared. I implore you, wherever you're watching from, to try these 2 formulae, and you will find out they will give you the same answer, and you will begin to respect science the more. But for want of time, we are going to use only the first formula, which is v squared minus u squared plus 2as. The final velocity v is 15. 15 squared is 225. Initial velocity u is 5. 5 squared is 25. 2 times acceleration. 2 times 2 acceleration is 2 here. And then s. In equations of motion, whenever you see s, it means distance. So s is what we are calculating. And when we go by that, we are going to have 50 meters. I have told you, you can try this second formula and also find out that you're going to have 50 meters. So the distance covered after 5 seconds rather, which is the first phase of the journey A, the distance covered is 50 meters. Alright, so I have told you, whether you use equation or you use equation of motion or you use calculate the area of the shape formed, you're going to get the same answer. That will be proved in the final question. Question 4 says calculate total distance covered, meaning the whole distance covered in the journey. And to help you as beginners, I've broken the journey into 3 parts, A, B, C, which I have explained: positive, uniform or constant, and then negative, that is deceleration. So to find the area of this figure formed, we are going to take it in parts, A, B, C. Part A, we had already found with an equation, is 50 meters. And when we find this, we are going to have 50 meters. Then part B will give us 15 times 5, that is 75 meters, which is the area of a rectangle. 15 times 5, 75 meters. And C, area of a triangle, half base times height. When we do that, we are going to get 37.5 meters. So what we will have is A plus B plus C. When we add up the 3, we are going to have 162.5 meters. That gives us the total journey covered. equation we used in A, you will find out that A is not a triangle. So it is a trapezium, and for that reason we said half of the two parallel sides, which is 5 and 15, times height. When you place it like that, you'll find out that the height is also 5. Half of the two parallel sides. The two parallel sides are 5 and 15. That's what you have here. So like I told you, times the height in this case, which is 5 meters. So 5 will be the height. So like what I told you, whether you use formula, any of these, or you use the, finding the area of the shape, you will arrive at the same answer. Finally, area of the figure found is the sum of the area of the three different shapes we have put together here. A plus B plus C. When we add them together, we have 162.5 meters. That is all we have for today. With this guideline, try your hands on some other sort of calculations of this nature. Most importantly, I say that again before I leave you today, note that in this journey, the initial velocity is not 0 because the object or the body is not starting from rest. Have a nice day. Happy holiday.